The next set of factoring problems that we're going to work on should look somewhat familiar as they're in a quadratic form. So when you see an even degree polynomial, what you'll notice is that even degree polynomials can be factored similar to quadratic. So if we have something like x to the fourth, that breaks up into x squared and x squared, which is just simply x squared squared. So it just becomes a quadratic term. And we can do this with pretty much any even degree function. So this allows us to use our quadratic factoring that we learned in the previous unit on higher degree polynomials. So that's what we'll do here in the sample problem. So if you look at example problem 2, part A and B, you can see the different types of quadratic factoring that you've done with higher degree polynomials. So let's just go on to the examples. If you go ahead and work those and then come back and check out the solution. On sample problem 2, what we have here is we technically have a difference of squares. 25 is a perfect square, x to the fourth is a perfect square, and negative 36 is a perfect square. So it's just like when we had difference of squares, we would break up each individual part. So we can see here 25x to the fourth will break up into 5x squared and 5x squared. 36 will break up into 6 and 6, and then since it was a difference of squares, that means we're going to have different signs. And so the difference here with factoring quadratic equations or quadratic expressions and factoring higher degree polynomials that are similar to quadratics is that we should always be looking for a second level of factoring to see if it's available. And in this case, it's not. 5x squared plus 6 cannot be factored, and 5x squared minus 6 can also not be factored. And so we will take a look at that each time. Okay, part B, we simply have an A and a B values, variables across the expression, but B squared is the most common term. So we're going to take that out first. And that leaves us with a perfect square trinomial inside the parentheses. So if we take a look at that, we have A and A. 16b squared can be broken up into 4b and 4b. And since 16b squared is a positive term, that means we have two signs that are the same, and in this case they'll both be negative, and of course we could rewrite that as a binomial squared. Alright, so there's some factoring, some quadratics factoring for higher degree polynomials.